I want to end this first lecture on multiple regression by, again, trying to drive home the different ways that we can think about what we're trying to achieve when we have multiple covariates that we think help predict or explain variation in an outcome. And again, I've used this example before, but again, going back to where we're interested in predicting incumbent party vote share, and we have two predictors, the second quarter GDP growth and June polling, we again are trying to fit one linear line through multiple dimensions, which inherently is going to adjust or alter the way that line is tipped, right? If there's data that's skewed or problematic in one of the variables, that's going to impact, the relationship that we're able to predict in the others. I guess less nefariously, if the covariates themselves are related to each other, that also is going to impact the way the line is tilted or sloped. So we can think about how that happens if we just keep it really simple and think of one covariate where we have two different groups. And that can take on 0 or 1. And we're going to go over dummy variables in the next module. But I think this is a really easy way of thinking about what exactly is happening when we add additional covariates to our regression. So before, we can think about it in a bivariate case. And if we have x equal to 0, then our predicted value of y is just going to be alpha, or the y-intercept. And if x equals 1, then we just have alpha plus our estimated beta. And again, we can do the same type of inference as we did last week with a t-test to see if there is a relationship that likely exists. And like I said, we'll talk about dummy regressions in the next module. But essentially, that's all that we're doing here. We're talking about additive relationships. And given that these relationships are right now additive, I think looking at added variable plots is also a helpful way of starting to think about what we're doing actually with regard to inference with regression, not necessarily the actual estimated construction. So here we can see for each variable, we have conditional on the other variable, what is the relationship between quarter two growth and like the voting percentage that an incumbent party receives. So again, I want you to think about this because one, I'm going to ask you to do these things in your homework and problem sets. So you're definitely going to have to look at additive models with dummy variables and groups. And I also think it's important because it kind of drives home the subtle ways in which these concepts are tied together. And so don't overthink it in the sense that these slopes of the lines of those added variable plots are literally just the beta estimates that you would get in a regression output or table. And some implications of this when we look at like an added variable plot is that by adding additional controls that are positively correlated to both the vote share and GDP, you're going to essentially lower the potential relationship, right, that GDP can explain of your outcome vote share. That's just inherently going to be the case by construction. So if you have many variables that are highly correlated, and we'll talk about this in our module with diagnostics with regard to multicollinearity, it's going to make the coefficients or your estimated relationships smaller, and it's also going to make them less reliable. It's going to increase your standard errors, right? So it's always going to be difficult to decide what the right variables are. And moving forward, I am going to teach you some wrong ways to go about selecting variables, but I always recommend that you use theory to guide what variables you include in your model, exactly for this reason, because you will have a good theoretical reason for why some of your covariates vary together. We have a good reason for thinking that the approval rating of a president in June before an election is going to be related to how well the economy is doing. So it's not surprising that if we insert that variable into our model, the potential amount of variation that quarter two growth has to explain in presidential vote share is inherently less. Now, for next time, we're going to move on how to make inferences from our multivariate regressions. Now that we've learned how to construct our betas as well as our standard errors around those estimates.